Unit 1, the alphabet and grammar of geometry. Lesson 1.2, the geometry alphabet. You should be on this page of your notes, watching this sometime on the 20th and 21st, prior to class on the 22nd and 23rd. Please make note of the location that you are watching the video, as well as the date and time. When you are finished, have a parent, guardian, teacher, or librarian sign off that they witnessed you doing these videos. Let's start with the review problem. We're going to review a radical problem and graphing. When we deal with radicals, we're going to follow PEMDAS here, which means we're going to do multiplication and division before we do addition and subtraction. So we have a multiplication problem right here. We multiply the outer numbers, 3 times 2, which is 6. Then we multiply the inner numbers, 2 times 6, which is going to be root 12. And then we go through and we collect like terms. We have a 1 root 2 here. So, and there's no other root 2, so that's 5 root 2. And then we have 2 root 5s, so that's going to be 7 minus 9, so that's going to be minus 2 root 5. Now there's one more step to simplify, because this root 12 here can be simplified, so root 12 equals square root of 4 times 3. And in 4 times 3, 4 is perfect. Therefore, it gets paroled, becomes 2 on the outside. That 2, we multiply times the 6 on the outside, and so our final answer is going to be 12 root 3 plus 5 root 2 minus 2 root 5. And that is as far as we can go because there's no more alike radicals. We're going to graph the following. There's 2 ways you can graph this, using intercepts or y equals mx plus b. I'm going to use intercepts, which means for the x-intercept, y is 0, x will be something. For the y-intercept, x is 0 and y will be something. So to think of this mentally, if we put a 0 in the y here, we say goodbye to this whole term. So we have 6x equals 12. Therefore, x is 2. And then if we look at it this way, we put a 0 in the x component, say goodbye to that, and we end up with negative 3y equals 12. Divide both sides by negative 3, we end up with y equals negative 4. Now we're going to plot those 2 points. We have 2, 0, which is right here. Whenever you graph an intercept, you want to plot the point, put the point at the label right next to the intercept, and 0, negative 4. And then you string a line between these 2 points. And then label. This is going to be 6x minus 3y equals 12. Now, in today's preview lesson, just like when you learn a language, the first step in learning any new language is learning that language alphabet. Whether it's the Arabic language or Spanish or Italian, there's an alphabet based on that language, at least alphabetic languages. In English, of course, there's 26 letters. Similar, geometry, there are letters in which we build the words of diagrams, but there's only 5 letters in geometry. The 5 letters are point, line, ray, segment, and plane. Before we talk about the letters, we first need to recap the concept of dimensions. Dimensions. We live in a 3D world, a world of 3 dimensions. That's why we like 3D movies, because 3D movies feel more real to us, because we live in 3 dimensions. Now, when you study physics, commonly the 4th dimension is considered time. Now, when we talk about dimensions, the first dimension is just length. The second dimension is something that has both length and width. And the third dimension includes length, width, and height. Now in geometry, as I said before, there's only 5 letters. Out of these 5 components, all diagrams that you will create in geometry consist of these 5 letters. They are a point, a line, a segment, a ray, and a plane. These are the 5 letters of geometry. Let's take a closer look at these. For a point, we name points by their letters. So if I put a capital letter, it has to be a capital letter. The symbol for that point A is just the capital letter A. Remember, you're going to use capital letters for these. And a point does not have length, it does not have width, it does not have height. So technically, it has 0 dimensions. Now a line must have arrows. A line goes on forever, both directions. Let me give you an example of how we name lines. We name lines by using any 2 letters on the line, just 2 letters. For example, this line I have here, I could call it line PQ, or excuse me, PR, with the little arrows. And because it has arrows both ways, I can flip that and call it RP. That would name the same line. You only need 2 points to make a line, so I could also call this QR, an RQ. Do you see any 2 combinations of letters? Now, there's a third way we can name this, or excuse me, second way, just any 2 letters combination, and the next way is if we use a lowercase italics or cursive letter. For example, let's say right at either arrow. Notice it's lowercase, so it's no longer a point, it's a name. We could call this whole line, line J. And remember, for a line, you must have arrows. And a line has length, but only length. So it is 1 dimension. Now a segment is a piece of a line. If I were to just take a chunk of this line and bring it down here, I could call this segment PR. Could also call it segment RP. If I bring in this additional point, then I have two additional segments. For example, that would be considered segment QR or RQ. Use capital letters. Or I could go this piece, and that would be segment QP or PQ, same thing. Notice no arrows now because it's pieces of a line. They have endpoints. So it ends with points. Like a line, it only has length, so it's also 1D. Now, array is also a piece of a line, but it just goes on forever in one direction. That's why there's one arrow. Now, for this, we would say it's PR, P on the left, R on the right, with an arrow to the right. P is the end point here. We cannot call this RP. So draw that, and then add a don't do this symbol. Why can we not call it RP? Because R is not the end point, it's the arrow side. So you have to start with the end point in array. It's also one dimension. Now, planes is just any flat surface or piece of a flat surface. So in a plane, we usually name it by the capital letters at the corners. So let's do WX. Notice these are points, so they're capital letters. And we name a plane going clockwise or counterclockwise any three letters. So I could go this way, any three letters, and I write the word plane. I can call that W, X, Y. I don't have to name Z. Just three letters is sufficient. Or I could even go plane X, Y, Z. Or I could start at Y and call it plane YZW. Any three letters. Now, if you're more comfortable, you can always use all four. Plane W, X, Y, Z. You have to go either clockwise or you can go counterclockwise, like so. I could call this as well plane WZY, going this way. Or to make it simple, plane WZYX. The only way you can't name this plane is what's called a Z formation. You cannot name it going in a Z formation. For example, WZXY. Trace that, physically trace. Do this with me. WZXY. You cannot Z label a plane. You have to go clockwise or counterclockwise. Now there's an additional way. You could use a cursive or italic letter in the upper right-hand corner, and that would name the whole plane. So I could put an italics or cursive M in the upper right-hand corner, and I could call this plane M. Notice it has to be italics or cursive. That names the whole plane. It's cursive. That way we know it's not physically a point. So on our tabletop here, we could actually see our entire alphabet. That would be a point. We take this edge and stretch it all the way across. That would be a line going on forever. If we stop right here, that is a segment. We draw an imaginary line going this way and have it go on forever in one direction. That would be a ray. And of course, the whole tabletop would represent a plane. That is the alphabet of geometry. One of the key skills in geometry is taking this alphabet and taking sentences and translating them into a diagram. Sentences and translating them into a diagram. Now there's a special way I want you to read all math problems. First thing I want you to do is actually physically put your finger at the beginning of this line. That's called finger, track, and read. So I want you to put your finger right at this word draw. Follow the little box here. Put your finger there. As I read, you're going to track your finger along with the words, left to right. This is so you don't lose out details. Ready? Let's put your finger right there and track with me as I read. Draw a line PQR with a ray PT and a ray QM. Now we're going to do what I call filtering, where we underline or highlight. If you have a highlighter, you can use a highlighter, the key words. Well, we have a line, that's important, and the line has the 3 points PQR. We have a ray PT and another ray QM. So we're done with the filtering step. I like to cross that out. Now, as we account for each component, we're going to cross it out. Let me show you what I mean. Step one, we're going to draw a line PQR. So I have a line. Doesn't matter which way PQR starts. Right to left, left to right. There's no directives in geometry. So now that I've accounted for line PQR, I'm going to cross it out. I'm done with that piece of information. Now we have another ray, PT. I'd like you to circle that P and circle this P. Connect them. Really important. If it's the same letter, it's the same point. Same letter, same point. Same letter, same point. Same letter, same point. So when we do array PT, we're going to start at P, that's our end point, and we're going to go towards the T. It doesn't matter which direction. T is going to be towards the arrow. I could have gone this way. There's no rule that says I had to go up, but I'm going to leave that up one, so there's only one here. We're done with this information. We cross it out. And another ray, QM, same letter, same point. Q, it's a ray, must have an arrow. M goes towards the arrow. Cross it out. Congratulations, you've done your first geometry translation. Let's try another one. I'd like you to put your finger, physically put your finger or your pencil right at that word draw. And now I'd like you to read aloud with me at the same time. Ready? Read and finger track. Draw a segment EF intersecting a line BC at point F on a plane WXYZ. Now we're going to filter. Either highlight or underline the key words. We have a segment EF. It intersects another line BC at a point F on plane WXYZ. Let's take this one step at a time. Okay, so we're done filtering. So we're going to draw a segment EF. No arrows because it's a segment. We cross it out when we're done. Intersecting at line BC. Intersecting means it's crosses, and we have a line, which means it has arrows, BC. At is the point of intersection, point F. So F, at means to cross, point F. Notice that's capital letter. Cross stuff out when you're done accounting for it. Now this entire diagram is on a plane WXYZ. So we draw a tabletop. Doesn't matter where we started. I'm going to put the W here, and there's two directions. We could label either this way, clockwise, or we can label this way, counterclockwise. What we cannot do is do a Z formation. So I'm going to go clockwise. So W, X, Y, and Z. Cross it out. Let's see how well you got this. I'd like you to finger track and read these two sentences. Filter your work by underlining, highlighting keywords, cross stuff out. Hit the pause button and try this on your own now. Okay. Welcome back. Let's see how you did. It says draw a plane Q with a line AB also on plane Q. Also a line Q intersects line AB at point R. Let's filter the key information. We have a plane Q. We have a line AB on plane Q. And we have a line Q. Notice the repetition in the letters there. There's a trick to that. Intersects line AB at point R. So we're going to start by doing a line Q. Notice that's a cursive Q, so that's not a point, or italics Q. It names the whole plane, so we do an italics cursive Q in the upper right-hand corner. When you're done, you cross it out. We have a line AB on the plane Q, so on the plane is AB. If you went left to right with AB, that's perfectly fine. And then it gets a little tricky. Then I talk about a line Q. Notice that's cursive and it's lowercase, so that's not that uppercase Q. It means a whole line, and it's going to intersect AB, so it cuts across AB. It's line Q, so at either arrow, either here or here, it doesn't matter. And it intersects at a point R. Notice that's a capital R, so it is a point. And you are done. Check your diagram, check my diagram, and see how close you got. We're going to do many more of these next class.